Alright, algebra. We are in chapter 9, section 1. Totally new stuff here, so I need you to pay attention with the warm-up. Make sure you understand where we're going. So we're doing triangles. Chapter 9 is all about trigonometric ratios and functions. 9.1 is use trigonometry with right triangles. I have a right triangle. A and B are the lengths of the legs. Okay? If it's right, this is a leg and this is a leg, and that's the hypotenuse. Find the missing length. So A and B are legs, C is the hypotenuse. If I know two of the sides, I need to use Pythagorean theorem to find the third. When it says give exact values, that means we don't do the square roots of anything in our calculator. Pythagorean theorem says a squared plus b squared equals c squared. So 6 squared plus 8 squared equals c squared. 36 plus 64 equals c squared. That seems to be 100. 36 plus 64 is 100 equals c squared. So square root of both sides. C equals 10. That's the length of the hypotenuse. Okay, let's try this one. We don't know A, but we know B and C. So a squared plus 49 equals 100. A squared equals 51. Square root of both sides. A equals the square root of 51. There's no plus or minus when you're talking about real measurements. If you walk 2 kilometers due east, then, I think that would be then 1.5 kilometers due north, how far will you be from your starting point? I'm going to start here. We've got north, south, west, east. I'm starting here. I'm walking due east, then due north. How far will you be from the starting point? Okay, right triangle. 2 kilometers, 1.5 kilometers. We don't know C. 2 squared plus 1.5 squared equals C squared. 4 plus 1.5 squared. I have C squared equals 6.25. Square root of both sides. C equals exactly 2.5 kilometers. Right, consider a right triangle that has an acute angle theta, the Greek letter theta. The 3 sides of the triangle are the hypotenuse, the side opposite theta, and the side adjacent to theta. Ratios of a right triangle's side lengths are used to define the 6 trigonometric functions: sine, cosine, tangent, cosecant, secant, and cotangent. On the next page you'll see that. Sine, cosine, tangent, cosecant, secant, and cotangent. Those are the abbreviations. Okay, these guys are sort of friends, these guys are friends, and these guys are friends. I always remember they're friends because they start with the opposite letter. I know that's silly, and not really opposite letter, but tangent and cotangent. Right triangle definitions of trig functions. Let theta be an acute angle of a right triangle. The 6 trig functions are defined as follows. Let me draw a triangle down here. It's a triangle that was on the previous slide, so you have it. If that's theta, that's my right angle. This is adjacent, and this is opposite, and this is my hypotenuse. So, sine of theta, so this is a ratio, so the sine of that angle theta is opposite, the length of this opposite side over the length of the hypotenuse. So we would type in the measurement of the opposite side of the triangle, divide by the measurement of the hypotenuse. Okay, cosine of theta would be the adjacent side of the triangle divided by the length of the hypotenuse. Okay, adjacent over hypotenuse. Tangent of angle theta is the measurement of the opposite side of the triangle divided by the adjacent side of the triangle. Okay, they're all ratios. What's really cool is I told you that sine and cosecant are friends because it's the reciprocal of the ratio. Cosine and secant, the reciprocal of the ratio. Tangent and cotangent, the reciprocal of the ratio. Now I said all of that because if I look down here, cosecant is really 1 over sine. Secant is 1 over cosine, and cotangent is 1 over tangent. Okay? Alright, let's try practice. Evaluate the 6 trig functions of the angle theta. First of all, I don't know all the measurements of the sides of the triangle, but I can figure them out. A squared plus b squared equals c squared. 25 So I've got 5 squared plus 12 squared equals 169. If I take the square root of that, I get 13. Now I can do all of the 6 trig functions. Sine equals adjacent over hypotenuse. No, sorry, opposite. Sine is opposite over hypotenuse. 12 over 13. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Now once you get those 3, the next 3 are simple because I just do the reciprocal. Cosecant, 13 over 12. Secant, 12 over 5. Sorry. And cotangent, 5 over 12. Sorry, secant is incorrect. I just saw that. Secant is 13 over 5. Not too bad, right? If theta is an acute angle of a right triangle and sine theta equals 4 over 7, what is tangent theta? So I need to draw my triangle. I'm going to name that theta, and that's right. We know sine is opposite over hypotenuse, so 4 over 7. I need to figure out what a is. A squared plus b squared equals c squared. A squared equals, a squared plus 16 equals 49. 49 minus 16 is 33. Square root of both sides. I'm going to say a is the square root of 33. So tangent is opposite over adjacent. 4 over the square root of 33. If you remember, back to the beginning of the year, I told you that mathematicians don't like radicals in the denominator. So we rationalize them by multiplying by the square root of 33 over the square root of 33. Multiply across the top, across the bottom, 4 root 33 over, that's now rationalized and it becomes 33. We're at B. Guided practice, okay? Evaluate the 6 trig functions, so I need to write them all down, but first I need to know what the hypotenuse is. 4 squared plus 3 squared equals c squared. 16 plus 9 is 25. C equals 5. Now remember, we do the first basic ones: sine, cosine, tangent. Sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. Tangent equals opposite over adjacent. And then we have the reciprocals. 5/3, 5/4, and 4/3. No decimals, just fractions. Because these are ratios, we like to keep them in fractions. Okay, try another one. This one I know A, I don't know B, and I know C. So I have 15 squared plus, nope, sorry. $17 squared, subtract 225 from both sides. Minus 225, 64. So B equals 8. Now we can do our functions. Sine, cosine, tangent. Sine is opposite over hypotenuse. Notice I'm going the opposite of the angle, no matter where the angle is. Adjacent over hypotenuse, it's the one next. Adjacent's the one next to the angle, and then opposite over adjacent. Cosecant, secant, cotangent. 17 over 15, 17 over 8, 8 over 15. Not too bad. Okay, last guided practice, I think. Maybe not. This one's crazy. Okay, I know C, I don't know A and B. I guess we could say that's A. A squared plus B squared equals C squared. Let's see, that hypotenuse is square the 5 and then square the root 2, which is just 2. So that's 50. Subtract 25 from both sides. And then square root. So A equals 5. Cool. Sine, cosine, tangent, cosecant, secant, cotangent, theta. So I have opposite over adjacent. Uh-oh. We have to rationalize that. Cosine is adjacent over hypotenuse. I'll get to the rationalizing. I didn't leave enough room. And then opposite over adjacent. Reciprocal, 5 root 2 over 5, 5 root 2 over 5, 5 over 5. All right, I assume you've written those 3 down. We need to fix all of them. They're very messy. They're not nice, neat answers. All right, I just wrote them down again. First of all, we're going to simplify. Equals 1 over root 2. Then I need to multiply by the denominator. That gives me root 2 over 2. And that can be a final answer. Same for this one. If you don't remember how to rationalize, please ask. Okay, I can help. Okay, hold on, be right back. All right, let's look at these. The blue, I just did the other 6 functions. When I take the reciprocal, I can cancel those out, and my answer is just a root 5. No, a root 2. Okay, same here. And here, ha, silly. There we go. In a right triangle, theta is an acute angle, and cosine theta is 7/10. Cosine is adjacent over hypotenuse. So I just drew a right triangle and did adjacent over hypotenuse. Now we need b, so 7 squared plus b squared equals 10 squared. 49, 100. 100 minus 49 is 51. We've already did this one. Oh, b squared is 51. Square root of both sides. B equals square root of 51. I just didn't leave enough room. The problem said sine of theta, right? That is opposite over hypotenuse. There we go. Nope. Alright, moving on. Special angles. The angles 30, 45, and 60 occur frequently in trig. You can use the trig values for these angles to find unknown side lengths in special right triangles. This right here is what I've memorized. The table isn't as helpful to me. We'll see if we can use it a little more, and it might be helpful to you. The table below gives the values of the 6 trig functions for the angles 30, 45, and 60. You can obtain these values from the triangles shown. These are special triangles. Let me get my pointer. This right here is the 30, 60, 90 triangle because of those angles, the 90. Okay, across from the 90-degree angle is the biggest number because this is the biggest angle. Across from the 30-degree the 30-degree angle is the smallest number because that's the smallest angle. And that's the medium angle, the medium measurement. Same here, across from the 90-degree angle, which is the biggest angle, I've got the biggest number. Across from the smaller angles, I have the smaller numbers, okay? It helps me remember where they go. Let's see if we can use these, though. Okay, you're going to need those special triangles handy. Find the value of x for the triangle shown. So, if you remember, the inside of a triangle, all the angles add up to 180. So if I subtract 90 and I subtract 30, I have 60 degrees left. So we know this is a special triangle. And I've said that across from the smallest angle is the 1. Here is the 2. And here is the square root 3. Let me go look. Yep, the square root 3. That's the special triangle that you see, right? Let me erase all that. I assume you're taking notes. Let's just do this. One, 2, root 3. That's the special triangle, right? So we can write an equation knowing that cosine of 30 equals adjacent over hypotenuse. So cosine of 30 equals, we know that cosine of 30 is adjacent over hypotenuse. So root 3 over 2 from our special triangle. That equals adjacent over hypotenuse, x over 8. I can cross multiply. I get 8 root 3 equals 2x. Divide both sides by 2. I have x equals 4 root 3. Pretty cool. So the length of side x is 4 root 3. I can crunch that in my calculator, but 4√3 is actually more accurate. All right, solving a triangle. Solving a triangle means we find all the unknown side lengths and angle measures of a triangle. So solving right triangles that have an acute angles other than 30, 45, and 60 may require the use of a calculator. To find the values of sine, cosine, and tangent functions on a calculator, those are the keys that you use, which are on your calculator. You can find them. Use these keys and the reciprocal key, which we don't have a reciprocal key, but we know that this flips a fraction. We have this key. Okay? Be sure your calculator is set in degree mode. If you hit your mode button, which is on the top row, it'll say radian or degree. You want degree. All right, let's try one of these. We're going to solve the right triangle, so I need all the angles and all the sides. If you look at the sides, I only have one of the three, so I cannot use Pythagorean theorem to find the other two. If you look at the angles, I have two of the three. So I can subtract 90, which is right there, and 28, which is right there, and I get 62 degrees for that third angle. Now I need to tackle the sides. So if I look at it, it doesn't matter, it doesn't matter if I do sine, cosine, or tangent. Let's go ahead and try tangent because it's opposite over adjacent. So opposite over adjacent, tangent of 28 equals a over 15. If I cross multiply, I get 15 tan 28 equals a. 15 times the tangent of 28. I typed in 15 times tan 28 and I get a is 7.98. Now I can use the Pythagorean theorem. A squared plus b squared equals c squared. So 7.98 squared plus 15 squared equals c squared. I still have 7.98 and a whole bunch of other numbers in my calculator, so I'm just going to use that and square it. Square root my answer. Oops. I get c equals 16.99. So I know A, B, C, and all the angles. I've solved it. All the angles, all the sides. Solve ABC using the diagram and the given measurements. It looks like C equals 5, B equals 45. This triangle's not drawn to scale, because if that's 45, then that one's 45 also. I know that, let's see. I need sine or cosine, so we're going to do sine of 45. If I look at that special triangle, the sine of 45 is 1 over the square root of 2, which is opposite over adjacent, opposite over hypotenuse, a over 5. So I can cross multiply here. I get 5 equals a root 2. Divide both sides by root 2. Nope. A equals 5 root 2. 5 over root 2. I need to rationalize it. So I get 5 root 2 over 2. So that is A. Amazingly enough, 45 90-degree angles, the legs are equal. So if A is 5 root 2 over 2, then B is also 5 root 2 over 2. So I've got A, I've got B, C was given to me, my angles 45 and 45, I'm good. I don't like that triangle that was drawn incorrectly. Here we know that A is 32 degrees, so I can do 180 minus 32 minus 90. That gives me 58. I know that B is 10. So adjacent over hypotenuse, opposite over adjacent. Let's do tangent again. Tangent of 32, you could use 58, is opposite over adjacent, so A over 10. I can cross multiply. I get 10 tan 32 equals A. Type it in, 10 times tangent of 32. A is 6.25. Now we can use A squared plus B squared equals C squared. 6.25 squared plus 10 squared equals C squared. Okay, take the square root of those two added together, and I get C equals 11.79. I have A, B, C, and both of my angles. Another one. A is 71. B is unknown. $19. C is 20. So I can use sine or cosine, not tangent. Let's use sine of 71 is opposite over hypotenuse, so A over 20. Cross multiply. 20 sine 71 equals A. A equals 18.91. So A squared plus B squared equals C squared, except we know what C is. Go ahead and solve that equation. I get B squared equals 42.40. B equals 6.51. Got A, B, C was given, two angles, I'm set. One more. B is 60, so this is a special triangle, that means that's 30, and A is 7. I know my special triangle, 30, 60, 2, 1, square root 3. A is 7. Okay, so I'm going to do tangent. I don't know why. We'll do tangent of 30. Let me think. Nope, let's do tangent of 60. I'll tell you why I decided that in a second. Opposite over adjacent, B over 7 equals opposite over adjacent, square root 3 over 1. Okay, cross multiply, I get B equals 7 root 3, and I can leave it as that. 7 root 3. Okay, why did I pick that? I really would rather have, when I set up my first equation, my variable in the numerator. It just makes life easier. It doesn't matter, we can still figure it out, and as you practice, make sure you ask questions, but I prefer my variable in the denominator. Okay, so we have B, we have A, let's find C. 7 squared plus 7 root 3 squared equals c squared. 7 squared plus 7 root 3 squared. 196 equals c squared. Square root of that. C equals 14. So I have A, B, C, and all the angles. Good job. All right. So while standing at Yavapai Point near the Grand Canyon, you measure an angle of 90 degrees between Powell Point and Woodforce Point, as shown. So you're standing here, you measure this and that is 90 degrees. But that's messy. You then walk to Powell Point, nice easy walk, right? And measure an angle of 96 degrees between Yavapai Point and Woodforce Point. The distance between Yavapai Point and Powell Point is about 2 miles. How wide is the Grand Canyon between Yavapai Point and Woodforce Point? Okay, so read that again to make sure you understand, but you measure this angle, then you walk over here and you measure this angle. So we know what that one is because we can do some addition and subtraction. So let's figure out that third angle. I have 180 minus 90 minus 76. 14 degrees. So this angle right here is 14 degrees. We're trying to find x. I don't even know if we need that angle. I do know that if I know 76, I can do opposite over adjacent and get the x. So tan of 76 equals opposite over adjacent. If I cross multiply, I know 2 times tangent of 76 equals x. 2 tan 76. X equals 8.02 miles. That wasn't too bad. I have a whole nother page. Angles of sight. Okay, angles of sight means really like you seeing something. If you look at a point above you, so if you're standing here, you look at a point above you, the angle that your line of sight makes with the line parallel to the ground is the angle of elevation. So you think if you're standing here on the ground and you look up to the top of a tree, okay, this angle is the angle of elevation. If you are standing on a tree and you look down, okay, this angle is the angle of depression. This is parallel. So I've got an angle of depression. Where here, this is the ground, I'm looking up, angle of elevation. These two angles have the same measurement. A parasailor is attached to a boat with a rope 300 feet long. The angle of elevation from the boat to the parasail is 48 degrees. Estimate the parasailor's height above the boat. A parasailor is, goodness, I've got a boat. Oh, drawing. That's a beautiful boat. I'm in the water. I've got a rope, 300 feet, and me with wings, I don't know. I'm not just hanging out there. I think I've got, a kite or something above me. The angle of elevation from the boat to the parasailor is 48 degrees. Estimate the parasailor's height above the boat. Okay, so I need that measurement. I can do, this is a right angle, opposite over hypotenuse, that's sine. So sine of 48 is opposite over hypotenuse. Cross multiply, 300 times sine of 48 equals x. x equals 222.9 feet. 223 feet above the boat. Whew. Okay, a little practice. In example 5, find the distance between Powell Point and Woodford Point. Okay, if you go back and look, that's terrible. Right angle, what was it, 76 degrees? Yep. 76 degrees, 2 miles. We said this was 13 degrees? 14 degrees, because I can add. Yep. We measured this unknown side as 8 feet, or 8 miles. And this was 2 miles. It wants to know this distance. Well, I'm just going to use Pythagorean theorem. 2 squared plus 8 squared equals x squared. Um, 68 square root of 68. About 8.2 miles. What if, in example 6, estimate the height of the parasailer above the boat if the angle is 38? So again, water, boat, goodness, 300 feet of rope, parasailer, but now I'm angle of elevation, the height, yep, 38 degrees. I'm still trying to find the height of the parasailer. So now opposite over hypotenuse. Okay, cross multiply. 300 times sine of 38. 185 feet. Still too tall. Your daily homework quiz. There you go. Last one. Nice work.